Hello class, welcome to Unit 9, Lesson 3. Today we're going to go ahead and solve quadratic equations that have complex solutions. When we're doing this, we want our final answer to be in the form a plus bi. Remember, a is the real part, and b is the imaginary part. So, our first example, it says to solve, and it says express in the form of a plus bi. Okay, so this one, I notice it's a quadratic, and there's two different b's going on here, but we have our quadratics that are ax squared plus bx plus c. Okay, and it's equal to 0. Whenever there's a b missing, you can solve it using the square root property. Okay, square root property. So for this one, I'm going to subtract 36 to the other side, which gives me negative 36. And then to get x by itself, we go ahead and take the square root. Extremely important, when you take the square root, there are two answers, positive and negative, and that's the square root of negative 36. Okay. The square root of negative makes it an I, but let's just break it apart. It's really negative 1 times 36. And then x is going to equal plus or minus the square root of negative 1. The square root of negative 1, remember, is equal to I. And then the square root of 36 is 6, so it is 6i. So it wants our final answer in a plus bi form, so our answer will be x equals 0, that's the real part, there is no real part, plus or minus 6i. Okay, so you can use the square root property, remember, when there is no b term, no term with just an x. Example 2, it is not the same way. This one has the standard form. So the first thing I would do is I would look at it and say, can I factor this? Can I multiply to 5 but add to 4? We know I can multiply to 5 with 5 and 1, but in order to add, I would have to have 5 minus 1, which would multiply to be a negative 5. So I cannot factor this one. Factoring is not possible in this scenario. So now what I'm going to do is go to the quadratic formula. Okay, I would write down who a is, who b is, and who c is. A is always in front of your x squared, so it's the number 1. B is your number in front of x, so 4, and then c is 5. And then we're going to plug it in the quadratic formula, so just remember it's negative b plus or minus the square root, b squared minus 4 times a times c, all over 2a. Okay, so let's plug it in. X equals opposite of b. It's currently a positive 4, so make it negative 4, plus or minus the square root, b squared. So 4 squared minus 4 times your a term times your c term, all over 2a. Then I would want to see what you have underneath your radical. So this is going to be 16 minus 20, which gives me negative 4. So I have the square root of negative 4 all over 2. Once again, this is really like the square root of negative 1 times 4. So then we will have negative 4 plus or minus. Square root of 4 is 2, square root of negative 1 is I. 2i all over 2. And since it has to be in the form a plus bi, I would divide each part by 2. So we will have negative 4 over 2 plus or minus 2i over 2, which reduces to negative 2 plus or minus I. So our answer is x equals negative 2 plus or minus I. There's my real part's a negative 2. My imaginary part is 1i. Okay. That is example 2. Example 3. I know there's going to be an imaginary part, and the way that's going to happen is with quadratic. You could try and factor it. It is not possible. So we're going to go ahead, plug it into our quadratic formula. In this case, we know a is 4, b is negative 24, and c is 37. So plug it in the quadratic. X is equal to the opposite of b, so positive 24 plus or minus the square root, my b squared, so negative 24 squared, minus 4 times our a, which is 4, times our c, which is 37, all over 2a, so 2 times 4. Okay, type this part into your calculator and get your number. I really need you guys to practice typing it in right now because there's people that always make mistakes on it on the test just typing that part in. So parenthesis negative 24, end your parenthesis, square it, then minus 4 times 37. When you do that, you should make sure that you get an answer of negative 16. So 24 plus or minus the square root of negative 16 all over 8. Then my square root of negative 16. I would think about this as a square root of negative 1 times 16. Square root of 16 is 4. Square root of negative 1 is I, so it'd be 4i. So I'll have 24 plus or minus 4i all over 8. Once again, I need it to be an a plus bi form, so I'm going to take each part and divide it by 8. And then, of course, I would reduce. So 24 divided by 8 gives me 3. Plus or minus 4 over 8 is 1/2 I. So my form a plus bi is 3 plus or minus 1/2 I. That is example 3. Example 4. This one looks a little different. I don't see a quadratic. So what I would do first of all is get a common denominator, or I would think about what my common denominator is and then multiply everybody by it. So right now, this is really over 1. So I have 1, 1, and x. This is over 1 as well. So my common denominator would be x. I'm going to take all my numerators times x. This gives me x squared plus 5x plus 7x over x, and then x times 0 is just 0. These will cancel, and so I have x squared plus 5x plus 7 equals 0. So whenever you have this x in the denominator, you just need to multiply by your common denominator to get rid of it. Okay. Now I would see quadratic, so I'm going to plug it in the quadratic formula. X equals the opposite of b, so negative 5, plus or minus the square root, b squared minus 4 times your a term times your c term, all over 2a. So we got negative 5 plus or minus square root. It'd be 25 minus 28, so negative 3. Yes, negative 3. So we'd have negative 3 all over 2. Negative 3, or sorry, at least 3, the square root of 3 is not a perfect square, so I'm going to leave it as a square root of 3, but the negative in front, it's really negative 1. I'm going to write I. So this is really negative 5 plus or minus I square root of 3 all over 2. And then to put it in our form a plus bi, divide each part by 2. So x will equal negative 5 over 2 plus or minus, I'm going to write the numbers first so we have the real part. It's really square root of 3 over 2i. That is writing it in our form of bi. So there is example 4. Okay. Example 5, I would say this one's a little bit different because it has a fraction in there. But we're going to solve it the same way. So a is equal to 1/4, b is equal to negative 5, and c is equal to 36. So we plug it in. X is equal to the opposite of b, so 5 plus or minus the square root of b squared, so negative 5 squared, minus 4 times a, 1/4, times c, 36. All over 2 times our a, 2 times 1/4. Okay. Now, I will have x equals 5 plus or minus, what do we got here? 4 times 1/4 would be 136. So I'd have 25 minus 36. You could put this into your calculator, the part underneath there. So 25 minus 36 is the square root of negative 11. And then 2 times 1/4 is 1/2. So we'd have 5 plus or minus the square root of negative 11. We'd have I, because I can bring out that, and then the square root of 11 is not perfect, so I square root of 11 all over 1/2. Okay, we're going to simplify. If you have a fraction, which is really this top piece, divided by this fraction, you can go ahead and multiply by its reciprocal, 2 over 1. This will cancel. So I need to distribute my 2. So x will equal 5 times 2, which is 10, plus or minus 2i square root of 11. Okay, and it's in the form a plus bi in that sense. Okay, so there it is. If you wanted to write it with the I at the end, you'd write 2 square root of 11 I. Make sure you're very clear that the I is not underneath your radical though. Both of those are good answers. Questions on example 5 or any of these, please make sure you write them down. Otherwise, your homework today, is page 290 or PDF page 319, 57 through 70. No calculators on this test, and by no calculators, I mean no graphing calculator. If you want to use a scientific, you can. So you might want to practice your homework using just a basic scientific calculator. If you have questions, feel free to message me. Otherwise, have a good day, and I'll see you later.